From example 10.6, calculating current by using Kirchhoff's rules. Find the current flowing in the circuit in figure 10.29. So below the figure 10.29, this circuit is combination of series and parallel configurations of resistors and voltage sources. This circuit cannot be analyzed using the techniques discussed in electromotive force but can be analyzed in Kirchhoff's rules. So the strategy here is this circuit is sufficiently complex that the current cannot be found using Ohm's law and the series parallel techniques. It is necessary to use Kirchhoff's rules. Then let's go to solution. Applying the junction and loop rules yields the following three equations. So we have three equations, and also we have three unknowns. So three equations ang required. So junction C, current 1 plus current 2 equals current 3. Loop EB CDE FA, current 1 times R1 plus R4 minus current 2 R2 plus R5 plus R6 is equals to V1 minus V3. For the loop CDE FC, current 2 times R2 plus R5 plus R6 plus current 3 times R3 is equal to V2 plus V3. And then simplify the equations by placing the unknowns on one side of the equations. So junction C, current 1 plus current 2 minus current 3 equals 0. Loop EBCDEFA. So current 1 times 3 ohms minus current 2 8 ohms equals 0.5 volts minus 2.30 volts. And then for the loop CDEFC, current 2 times 8 ohms plus current 3, which is 1 ohm, equals 0.6 volts plus 2.30 volts. Then simplify the equations. The first loop equation can be simplified by dividing both sides sa 3. And then sa second loop equation can be simplified by dividing both sides by 6. So junction C, current 1 plus current 2 minus current 3 equals 0. Then for the loop EBCDEFA, current 1 times 3 ohms minus current 2 8 ohms is equal to negative 1.8 volts. For the loop CDEFC, current 2 times 8 ohms plus current 3, which is times 1 ohm, equals 2 volts. So the result is ang current 1 ihang value is 0.20 ampere, and then the current 2 is equal to 0.30 ampere, and current 3 is equal to 0.50 ampere. From example 10.7, calculating current by using Kirchhoff's rules. Find the current flowing in the circuit in figure 10.30. So the below is the figure 10.30. This circuit consists of 3 resistors and 2 batteries connected in series. Note that the batteries are connected with opposite polarities. So the given here is R1 is equivalent to 10 ohms, R2 is 30 ohms, R3 20 ohms, B1 is equals to 12 volts, and V2 is 24 volts. Applying the junction rule yields the following three equations. We have one unknown, so one equation is required. Then loop ABCDA, negative IR1 minus B1 minus IR2 plus B2 minus IR3 is equal to 0. So we're going to simplify the equation by placing the unknowns on one side of the equations. So we're going to use the values that given in the figure. So I times R1 plus R2 plus R3 is equal to B2 minus B1. So I is equal to B2 minus B1 all over R1 plus R2 plus R3, and then substitute the values, which is 24 volts minus 12 volts all over 10 ohms plus 30 ohms plus 10 ohms, and then we arrive the answer 0.20 ampere.